All right, now further down in the program, once I've grabbed a hold of the peg. This is the command that closes the gripper, and then pulled it out of the hole. Right at that point, I'm going to insert a whole bunch of lines because I want to do a whole bunch of things. What I'm going to do in here after I've gripped it is first change the tool center point to the end of the peg. Then I'm going to change the user frame to the user frame 3, which is the user frame that matches the template that I'm going to be tracing. And then I'm going to call a square program that I've already got written. I don't have to rewrite that. And then we'll just see if we can do that whole thing and get the peg back into the hole, and that'll be our loop. Okay. So right now I just have to insert a whole bunch of lines just so I have plenty of space to work with. Okay, so what I'm going to do now is enter the command to change the user tool Z direction, Z value back to 167, which is stored in position register 8. So the command is instruction, offset frames, user tool. I enter 2 for user tool, and I enter position register number 8, and that's grip with peg. All right, so now I'm going to jog it away from the fixture so that it's not going to do anything crazy, and I'll reteach a point. So I'm going to go in the Y direction. Oops, I'm still in tool, so I want to go back to world jogging. Move it away. Maybe rotate about X. Okay, I'm going to teach that point. Actually, what I'm going to do also is to change the user frame now to user frame 3, because that's the one that's going to be used to trace the shape. So, under instruction, go to frames, user frame number, select constant, and I'll put in 3. And then I'm going to record this point, and that's going to just be a joint move, because doesn't need to move in a straight line or anything. So all I did is I changed the tool frame based on the position register. I changed the user frame, and I recorded the point where it is now. So that's going to be kind of its starting point. And then I'm just going to do the shape. So this one, because I've already got it written, I can just do a call. Call program, and program is EEJH square. And once I'm done with that, I'm going to go back to the point that I'm at right now, so that's 0.5. I don't need to create a new point. I'm just going to call that 0.5. And then I'm going to go back to, see, right at this point I don't need to teach new points. So because this 0.4 is the point after the peg has been pulled out of the hole, so I want to go back to that 0.4. And the point right before that, 0.3, is where the peg is in the hole. So I'm going to go ahead and just teach the 0.4, kind of going in reverse, 5, 4, back to 0.3. And let me just, I'm going to run the program up to that point, just to test and make sure everything is going to be working, and then we'll deal with the rest of it, pulling the gripper back out of the hole and turning it off. One important thing, however, that I almost forgot, is that when the program starts, before anything starts, I want to make sure the gripper, if it happened to be closed based on some other thing that someone was doing, I want to make sure the gripper is open at the beginning of the program. So right after I've set the user and tool frame and set the tool frame to be the gripper tool frame, I've got to insert a command to make sure that the gripper is open. So I'm going to do instruction IO robot output 4 and off. All right, so this is a good time to test the program, see how it goes up to this point. I put it in step mode, and I'm going to go ahead and, you know, what I can do, since right now it's at joint 5, this is actually a good way to get the peg back in the hole without me having to put it in, and also a good way to test what I've done so far. So I'm at point 5. I'm just going to jog it back to point 4. That was the point right before going in the hole. I'm going to slow it down a little bit. I don't want to be moving too fast when I'm testing. So here it goes back into the hole. Okay, and at this point I'm just going to manually open the gripper using the IO menu. Okay. And I want to jog back out, so I'm going to do tool coordinate system, and to go back out, I'm going in the negative Z direction. So I'm going to do a negative Z direction, comes back out, and once I'm clear, I'm going to go back to the program and just run it up to that point. Okay, so let's go to the very top of the program, make sure everything's going to run. And really, I'm interested to make sure that the user frame change works. So let's do this. Oops, I'll move the camera in a little bit and tilt it down so you can see the peg and also the shape template. So starting at the top of the program, stepping through, setting the user to, so it's going to go back to home position. Speed it up just for the first couple of moves, and then I'll slow it back down again. So from home, I have it coming down close to the gripper. Now I'm going to slow it down. And from there, it then shifts to the angled position. Okay. Go straight down onto the peg, and that should be, okay, grips the peg, comes straight back out of the hole. Now at this point, I'm changing the user tool center point to here. That's the point that's going to be used to trace the shape. You don't see anything move there, but it just happened. And then the user frame is now user frame 3. And I'm just jogging into a position that's a little further away from the fixture. And now I've called the square program. Oh, I forgot, this one starts at home. Okay, so let's see how this goes. Square program comes down to the shape, traces the square, back to home. Okay, and now it goes back to the program, back to 0.5, back to 0.4, and slow it down a little bit. Oh, I just realized I forgot something. I need, when it goes back to 0.5, I need to change the tool center point back. It now thinks the tool center point is here, but it's supposed to be here. So that would be right before 0.4. So let's insert. And then we'll use that instruction. To change the tool center point back to just the gripper. And we'll test it from the point right before that. Okay, so this is where I'm going to slow it down a little bit. Okay, and that's as far as we got. So right now, we should be able to reuse some of the points we've already created, which are, so the first thing I want to do, now that I've got the peg back in the hole, this is at position 3, I'm going to open the gripper. So I need a command to do that. IO robot output 4 equals off. So I just entered the command. It didn't do anything because it hasn't executed yet. So I'm going to go ahead and execute it. All right. And now, what I'm going to do is just do so if I go back in the program, I want to go back to the point, it's 0.2, the point right before where it is now when it was coming in to grip the gripper. So there's no point in reinventing the wheel. I'm going to teach that. It has to be a linear move. And I just taught the point. I'm just going to enter a 2. That's going to get me to the right position. So here we are. Go forward. 0.2 is just clearing the gripper. And then at this point we can go back to home. We don't have to do anything else. So I'll just do one more point. This is going to be a joint move. And I just go over here, change the point to position register 1, and we're back at home. So let me just execute that. Okay, so we now have a program that we could put into a loop. We have it go down, pick the peg up, trace the shape, put the peg back in, go back to home, and it should do that continually. So the key here was, remember, getting a program that can reliably get that peg into the hole and back out without disturbing the fixture, and be able to switch user frame and tool frame to be able to come out, basically orient itself to a different fixture, a different workspace that's on an angle, and then go back to the world frame for the rest of the program.